Hello, my name is Justin Trupiano. I am a PhD candidate in Emergent Technology and Media Arts Practices at the University of Colorado. So, one of the major questions that I want to ask with my research is, what effect does sensory input have on behavior? Now, I think about this in a lot of different terms. In how social media affects humans and how pheromone trails affect ants. And all of these ideas are sort of boiled down into these pure artificial life simulations that I am creating here. The simulations that I want to talk about here are products of a much larger library of artificial life simulations, a library that I'm building for the Unity game engine. So now this particular simulation has about 1,000 agents. Each one of them can sense their immediate environment. So it's a 2D environment. They're moving around basically on the surface of this image, and they can sense the colors of the pixels in their immediate vicinity. This illustration kind of gives an example of that. We can see that each pixel has 3 values: red, green, and blue. Those values are between 0 and 1, depending on the intensity of each color. And those numbers are then fed into a neural network that is unique to each agent. The reason that's important is that the output of those neural networks is then used to determine the direction that the agent is going to move. And so if we imagine the standard feed-forward neural network, such as pictured here, we would have 27 inputs, 3 for each of the 9 adjacent pixels, and then 9 outputs, 1 for each of the possible directions, again, up, down, left, right, and the diagonals. Now, instead of using a traditional backpropagation type of learning, I really wanted the behavior to emerge just from the process itself. And so for the weights of the neural network, I'm using them as actually a sort of genetic code. So each generation inherits the weights of the previous generation's neural networks, specifically the fittest among them. The fitness parameter here being how many energy sources can they find, the energy sources being those little gray dots in the simulation. And so just to quickly go back to that original question, we can now sort of see how the sensory input for each agent is directly influencing the behavior of that agent. And so just to show the versatility of this library that I'm in the process of building, I wanted to show this other artificial life simulation that I've been working on. This one is loosely modeled on the spontaneous synchronization of certain firefly species. In much the same way as the previous agents, they're sensing their environment, and then those senses are directly tied into their behavior. In this case, it is how many of their neighboring fireflies are flashing, and then that will determine if an individual firefly flashes. And then much like the previous version, this also evolves through time, the fittest of the agents being those who happen to sync with the most number of other fireflies. And so with that, I will end it, and thank you for your time, and I look forward to the Q&A with all of you.